Good morning, Year 10. In this video, we're going to talk about the solutions to the 5 questions for week 1, term 3 on Wednesday. For question 1, question 1 and 2 are both a revision from yesterday's lesson. The first, write 3 to the power of x equals 27 as a logarithm. So we're going to use the BAP method for this. The first thing I'm going to do is recognize that 3 is the base, x is the power, and 27 is the answer for this equation. Now I'm going to rewrite it as a log, because that's what it's asking me to do, where the base is 3, and remember we're doing it in BAP form, so it should look like this. BAP. So my A is 27, and my power is x. For question 2, it already is in BAP form, and we need to write it in index form, so it's the reverse. So I'm going to annotate by saying BAP, and now that means I've got a base of 2, a power of x, and the answer is 16. That's all I need to do for that one, just BAP in reverse. For question 3, I need to solve x squared minus 3x minus 4 is equal to 0. So for this, I'm going to do the product sum method. And so the product needs to equal -4, and the sum needs to equal -3. So I always like to start off with 1 and itself, so we'll see if that works. So 1 and -4, when multiplied, gives us -4. And when added, it gives us -3 as well. So that is definitely what we want for this equation. So I'm going to take those two numbers and I'm going to rewrite it. X plus 1, x minus 4 is equal to 0. And remember, we want to find when this set of brackets is equal to 0, because if it was, then 0 times anything will give us 0. And same for the other way, if this was equal to 0, then 0 times anything will give us 0. So that's what we're going to do. The quick way of doing this is just doing the reverse of whatever is happening here. So in this case, the solution will be x can be -1, because -1 plus 1 gives us 0. And x could also be 4, because 4 minus 4 will give us 0. So that's our answer for that question. For question 4, it says find the surface area of the triangular prism below. So we need to find the area of this face, which is also the same area as this face. We need to find the area of this base, and we need to find the area of this top face, and then the side face we need to find as well. So first of all, let's do the triangle. So I'm going to say the area of the triangle, so that's my way of saying I'm finding the area of the triangle. Remember, is half times base times height. So that's just going to be a half times 5 times 4. So the area of that will be, it should be 10. And there's no units, so I'm just going to write units squared, because it could be for any unit. Now I've got 3 rectangles to do, so I'm going to write A1, so this will just be the first one. And I think I'll do this one here, the side. I'll make that my area 1, so I'm just going to mark that on the page as my area 1. And that's going to just be 4 times 10, which is 40. I'm going to do area 2, which I'll do as the base. So I'm just going to draw a little thing, and so it's area 2 underneath, and that's going to be 5 times 10, which is 50. And then the last one, which is this face here, is going to be A3. Now we can't actually do it yet because it's going to be this side times this side, and we don't have this length here. So I'm going to have to use Pythagoras to find it. So I'm going to do that over here on the left-hand side. So remember, to find the long side, it's going to be a squared plus b squared is equal to c squared. So this is our c. Just going to highlight it there to make it clear. That length here is C. So I'm going to have, now A and B can be either, it doesn't matter, we can switch them around. So I'm going to do 4 squared plus 5 squared is equal to C squared. So 4 squared, that's 16. 5 squared is 25. And that, of course, is equal to C squared. 16 plus 25 is going to be 41. And now I just need to find the square root of 41 to find C. So C is equal to the square root of 41. I'll just remind everyone that that is an exact form. And I'll just write it in decimal form as well, but depending on what the question asks, you could do either. And if it doesn't specify, whichever one you prefer. So that one would be, we'll do 1 decimal place, is 6.4 to 1 decimal place. So now I know what C is, I can find my A3. So A3 is going to be C, which is 6.4, times 10, which is 64. But that's not the surface area, it's just the area of each side. So now we need to add it all together. So the final surface area, which I'll write up here, surface area, is going to be 10 plus 10, because I'm doing 2 of the triangles, plus 40, plus 50, plus 64. And if I type that into my calculator, because don't really feel like doing it in my head right now, I suppose, gives me 174 units squared. And I'll just clean that up because I actually didn't write units squared for each of these. I should. And that's the answer there. I'll just highlight it for this question. I'm not a huge fan of surface area just because the amount of working required. And it's all quite simple working, it's just a lot. So, question 5, the last question for now. Given A is equal to 2, B is equal to 3, and that's a capital C is equal to 60 degrees, find little c. If C squared is equal to A squared plus B squared minus 2AB cos C to 2 decimal places. So I'm just going to substitute in what I know and we'll see where we can go from there. So I don't have C because that's what I'm trying to find. A squared, that's 2 squared. B is 3 squared. And we've got 2 lots of 2 times 3, and I like to do it in brackets, just makes it a bit cleaner. And we've got cos of 60. Okay, and that gives me C squared. So I'm going to type that all into the calculator, see what I get. And that gives me 7. But it asks to find C. So I'm going to have to find the square root of 7. And the square root of 7 to 2 decimal places is what it wants, is 2.65. And that's to 2 decimal places. That's the answer there. All right. So that's the solutions for the 5 questions